Okay, this is a lab. It's an example of a couple videos that I threw together as a pre-lab for my chemistry kids. Now, the purpose of this was to stop from getting stupid questions over and over and over again during the lab, because lab time is precious. And, the kids need to know, or need to actually see somebody perform the lab first in the pre-lab, and that's why I videotaped this, so they could actually see somebody performing the lab, and then when they finally get to do the lab themselves, then that lab is a lot easier for them, so they don't have so many questions. It turned out really well, saved a bunch of time. Well, then after they get the lab done, what I did was they have a lab worksheet they have to fill out, just like every other lab, except for this time, what I did was I put all the lab questions on a survey form, and I'll show you guys that survey today. And when they put their answers in the survey form, what they're going to do is when they hit submit, it instantly comes back to me, and then I get this big spreadsheet of all their answers, and I can look through it pretty simply. Now, the whole purpose of this video is to find out really what happens with this stuff later on. The kids get the anhydrous CuSO4, and it's a white crystal, and then they pour some water into it, and there's an exothermic reaction that happens. Well, I tried to reuse some of that, but it never did hydrate again like I wanted it to, so I crushed it down and put it in this Erlenmeyer flask, added some water, let it sit for a while, and then after about an hour or so I come back and I get that nice blue color on there representing the CuSO4. I decant it out, so I have and I would keep doing this because you see at the bottom there's still some of that crystal left over, but I have some copper sulfate solution here. So what do you do with copper sulfate solution? Well, I grab some steel wool, and of course when you take steel wool and you put it in a test tube, or you put it in whatever, or then I would add some copper sulfate to it, and I would get this nice reaction, which kind of wowed the students. And the point is, instead of trashing that copper sulfate that I had, I can reuse it in another reaction. Bam! Immediately, iron sulfate reacts with this hydrogen peroxide. That's amazing. What's going on? Look at the color change. It's gone from two clear substances to this nasty brown stuff. Well, it turns out to be most likely the iron oxide. And then what else is going on there? That's a fast reaction. That's almost like a catalyst, but is it a catalyst? We're going to talk about that on the survey. Now look at the copper sulfate. It's taken a while, but what is it doing? It looks like it's starting and stopping. What? Why doesn't it just go? What's going on here? Why does it start and stop? And then it gets to a certain point and it goes on to reaction. Or it reacts to completion. Now look at the iron sulfate solution mixed with the hydrogen peroxide solution. The color change is immediate. There's a precipitate at the bottom. It's all nasty brown. It's not what either one of those look like. Now look at the copper sulfate. Well, that looks like copper sulfate, just with less stuff in it. So, is it a catalyst? Is it not a catalyst? I don't know. That's why I'm asking you. Then I did another experiment. I did just the the copper sulfate, I believe. Yep, it's coming up here. And I just put, was it 3 milliliters of H2O2 and just a few, I dropped some more drops in there and just let it go to completion. But I do this again just to see it start and stop and start and stop and start and stop. It's just so interesting to see, because usually when a reaction happens, it just happens. Don't know why it's kind of pausing there for a minute. And that's one of the survey questions I got for you. Is why do you think there's a pause there? Why doesn't it just fizz out like the iron sulfate? What's going on here? So this reaction occurs. I mess around with it, and it leaves this nasty. It leaves copper on the index card at the bottom too. With the stuff that spilled out, did you see that? It came down the test tube, left a big pile of stuff. Well, that's the copper. When I looked at it, it's copper. The index card is coated with it. Now look at it. It's back to its bluish color for copper sulfate. So I'm thinking, maybe that is just a catalyst, because a catalyst is there at the beginning, but then it's also there at the end of a reaction. Well, now I take it one step further. I'm going to try and get some temperatures on this thing as this reaction happens. Now, I don't have as much H2O2 in the test tube to begin with, and I just squirt it with a little copper sulfate because I don't want it all over my thermometer, the white part. So I just mix a little bit of it, and all the liquids and all the substances are at room temperature, and I almost spill it there, but that's okay because I caught it. And I have to play this at double speed because otherwise this takes forever. But you can see the increase in temperature. There it goes. There's some steam coming out, or not steam, but some gas coming out of there, and then now it's at 82.9, and then it starts dropping back. Okay, that's a big temperature difference. Now I've got my iron sulfate, and this goes quick, so I gotta put the temperature, the thermometer right in there. I figured at first, well, this is a more violent reaction. It should get hotter, but it doesn't. It doesn't get as hot as the copper sulfate. So what's going on? I have no idea. And, well, I kind of do have an idea. I mean, maybe. Maybe it's a catalyst reaction with the copper sulfate, but with the iron sulfate, it's definitely not. Because the iron sulfate changes color. I mean, it changes the stuff. And before I had thought that maybe the difference between the reactions, like the iron was so high is because, or so much more than copper, is because iron is higher on the activity series than copper. So, I mean, I don't know. But it also reminded me of the old foamy reaction where you dump potassium iodide in there. Now there is a color change with the iodide, and that's supposed to be a catalyst too. If you look at it, it changes colors. It still stains yellow or whatever it is. So, is it a catalyst? Is it not?